Well, hi, good morning. Thank you for coming and joining me here today. Another snowy day. Oh my gosh, I think there's probably 2.5 feet of snow on the ground outside now. A little more coming today and tomorrow too. But I'm inside, away from the snow, and I'm ready to go a nice big step with this radio, and that's to get rid of all those old capacitors now. Now that the radio is operating, I'm not so anxious about going ahead and doing more changes to the radio. Until the radio operates to any degree at all, I'm pretty anxious about working on it, because it's hard to detect your mistakes. I made a few on the way to get to this point. Once the radio's working, it's a lot easier to tell if you make a mistake. So the way I'm looking at this radio is I think I'm going to break it into 3 basic pieces. And that would be the audio section down here, the IF section kind of in here, and the RF section over this way, roughly. So first I'm going to change the capacitors in the the AF section. We'll start kind of from the speaker and work our way towards the antenna here. So those capacitors, well, they're pretty sure they involve this one. This one, I believe, is conveying the audio to the grid of the triode. Here's a green wire. They like to use green wires on grids. So this is the audio preamp, and they can actually see the green wire going right there. So this one could be responsible for a loss of volume if it's not got its capacity. This guy's right in the neighborhood here, but I'm not sure what he's up to. This is the tone control. This is the tone capacitor. I can see its connection to the tone control here. So we have the audio through it and the tone dumped down it capacitors. Now if we look at these two, see this one's coming from the IF, and this one looks like it's involved in the audio too. So we'll do that, turn on the radio, see what's left of it. Okay, that's the first 3 capacitors done. That's here, here, and here. And I also took a moment and changed the resistor down here because it just had such a terrible look to it. Okay, so let's give the radio a test and see if it's still working. It may even be working better. Well, I guess it's either working exactly the same or better. It better not be working worse. Sure everything is good here to go. Okay, I'm going to go through the dim bulbs. Okay, wait a minute. Okay, let's try it like this. Here we go again. Okay. Perfect. Those bulbs are doing just what they should do. And it shows the rush of current into the heaters of the tubes till they warm up a bit. And we had an antenna on here yesterday, didn't we? Yeah. Get ready with that. Current draw is normal. Did I say something about it should only get better? Oh my. We're only at 71 volts. Let's push it up a little higher. Come on, little radio. I was really careful when I did these capacitors. How could you not be working now? Holy smokes. Wow. Well, this is why you test radios as you do this work. There's nothing. Okay, inject a little signal here. Nothing coming out at all. I made one change towards that tube there. Grid signals coming right in here. Falling in the green wire right over to this capacitor I did. I tested this capacitor before I put it in even. Okay, let's get the signal tracer going and find out. I think we're going to find the audio is fine on one side here and it's just not making it through to the other. And I put in a bad capacitor. Don't see how that could be. Don't see how that could be. Okay, volume down. Didn't put the ground on. Chicken. Always chicken. No audio there. No audio there. No audio. You broke the radio, chumps, again. Once again, you've broken the radio. Oh, maybe we have the volume down. Let's try that again. Okay, so there's the radio. Oh, it's over here too. Why not coming out? Pretty loud up there. Wow, sorry about that. Here, let's turn this down. Okay, tune the radio a bit here. Audio's making it all the way to here. It's beyond here where it's in trouble. Well, maybe it's just very, very quiet. It's a very quiet radio still. Let's turn this down. Give it a chance here. Coming out. Okay. Seems a little muffled, but okay. We're good. We're good. That's good. That's good enough. As long as something is getting from the antenna out to the speaker, I'm happy. So, kill the power here before we get ourselves in trouble. I'm left now with one. This big whopper up here I'm quite suspicious of. Two. That's it. Just two. Okay. Just two. Okay, we're ready for another test. This one here. Good. That's it for the paper capacitor. Oh, is there one hidden up on top here? Let's just find out. Sometimes there is. And you see all these coils? Sometimes they hide a little capacitor in there. And there's one. There is one in there. We gotta take a look at this one. This is a special. This is a special. Let me switch cameras here. Pretty sure. So hidden back there is a capacitor. What makes it special is I think it has a metal covering there. Maybe not, eh? Ooh, it's in bad shape. Look at the crack in the wax. You can't imagine that's hermetically sealed. Now, is that what's it connected to down there? That wire? Well, let me wiggle it. Is it soldered right to the bottom here? I've got to set the camera down. Doesn't want to cooperate here. Just sit there for a minute, would you? Okay, there, I got it. Wow, it's pretty darn solid. Is it soldered to the... Can they even solder it to the chassis down there? Looks like it. Or is that a hole? Is it going down through a hole there and showing up underneath? Look at the dust. There's a hole. And it's going down through the hole. So I should be able to find that underneath. Okay, that's a little challenging. So the way I found to do this for me, trying to locate, top and bottom, I use my finger. It's a little tough here. Put my finger, yeah, I'll do it that way. Put my finger where the part is. This is not going to work very well. And then with my finger there, it's really kind of easy to look and see the spot right there. And what's coming through there? There's there's 3 wires coming through there now. Is that the right one? That is not the right one. The right one. How many are there? Just 2 holes. Hole that lines up with this. So a hole back in there somewhere. There it is. I can barely see it. There's only a wire coming through. Just 1 wire. There's no capacitor coming through. No capacitor lead. What's going on with that capacitor there? Here we are. This is the cemetery here. Haven't buried them yet. Can we get down there and see that? Maybe from the other side? It's not possible to solder it down like that. How can you do that? The wire, there's got to be a wire coming from down there. No, can't get in that way. Not too many angles to look at this from. Okay, let me change the focus here. It's going to take just a second. Let's see if we can focus our way down to the area of interest. It's just too far away to really see what they've done. What have they done with that little capacitor? I suppose I could try to identify it on the schematic and then figure out if the lead is going to ground. Where is it? It's totally out of view behind the coil. Can't get through here. Can't look from over there. Hey, this is a dumb situation. 0.05. So I'm going to try to find this on the schematic, and I suspect it's soldered right there, soldered right there. I don't know. Okay, so in the parts list, as best I can make out, that capacitor is called a low loss capacitor. What's that exactly? Probably in today's world, every modern capacitor is low loss, and this is probably a better than normal capacitor back in the day, way back there. So I think I should just kind of rip it out of there. I can nip it off the top here easy enough. Ooh, look where it's going. It's not as simple as I thought. I should be able to push the top over quite a ways here. Can't push it at all. It's a very, very mysterious thing here. Can't get my finger down in there. That's as solid as can be. How did they manage to do that? Am I missing something here? Let me just see if I can feel a wire down here. No. They bring the lead down through the little hole and solder it on the inside of the chassis, and there's an electronic reason for doing that too. Let's see if that's the case, because if that is the case, I better do exactly the same with the replacement capacitor. I gotta get in there with the camera. I think I have the focus set far. Let me move it up closer here. That. Now, the hole is down there. That's the hole. I sure don't see anything but a wire coming out of it. A single wire. Let me see if I can get this a little deeper in here. There. Now, how do I know for sure I'm looking at the right hole? I may not be. I think the right hole is over this way further. I think that's the correct hole there. So it's got a brownish wire coming through it. And from the top side here, hey look, I'm pretty sure it was a brownish wire. It's a nearly impossible to see wire. It's a brownish wire. Hey, you know what I can see from here? Hey, never mind that angle. Look at this. I was in the wrong hole still. Look down, look down somewhere. Where are we looking? We're looking down. Okay, I got to change the focus here because it's too far away. Right, focus. Yeah, I got to focus. Change my own focus here. Okay, now we're looking down. Looking down through there. There. So there's the brown wire coming through the hole. There's the capacitor lead soldered on the inside of the chassis. And that's not for the sake of convenience, that's for sure. That's done on purpose. Because there is an effect between the inside of the chassis, the surface of the inside of the chassis, and the surface of the outside of the chassis. And I'm not in a position to explain it at all. I just know it exists and it's a concern. So for instance, this capacitor must be soldered to the inside of the chassis, just like this one. Look at the job they did on it. How am I going to do that? How am I going to do that way the heck down there? Maybe from here. This doesn't look so bad. Yeah, you know what it is? It's the angle the entire radio is on my bench. It's making it difficult for me to see the obvious. The easy. Let's make it easy. Let's make it easy here. Well, that is really easy looking now. I think I want to tip this way up this way. Way up this way. Ah, that's not bad. It's a funny angle, but it's not bad. There it is, right there. Look at that. You can see it in the longer range camera too. So I'm going to try to nip that wire as far towards the capacitor, leave as much of a leg as possible under there, and then we'll stick the new capacitor down through there and solder it under. Hopefully I'll leave enough leg to because resoldering right to the chassis, not easy to do. You practically need a blowtorch there. Wow, I'm not going to get much wire this way. It would be better off ripping the heck out of the capacitor off the top to try to preserve as much wire lead as possible, or hook it and yank it down and rip it out of the bottom of the capacitor somehow. Is that even possible? That's a question of strength. Okay, so I need a good tool here to try to get in there and lever that thing down. You know, it's not going to go anywhere. There just isn't enough in there for me to get a grip on. Better choice is to try to rip the capacitor off from the top. Okay, let's flip it over here. You just rip it off. See, rip this baby off of here without damaging anything. Apply He-Man power, but don't damage anything in here. Looks like I can fish a screwdriver up under it there and kind of I'm going to nip away the top wire now. I don't want to make any mistakes here. And nip off a lead wire or somehow damage these coils. These coils are... This is what you don't want to have break down. These coils, you do not want them to be damaged or anything on account of. It's really tough to deal with it. This is not easy either. I'd like to have some idea what it is I'm about to cut though. Good. Got something. Something got cut. Let's see if I can just move it away a bit here. Okay. Now the ripping off of this. Give me a big, powerful screwdriver here. This is a good starter. Slide it in. Is it long enough? Not really. Not really. Let's go bigger and badder. Oh, that's bigger and badder. Okay, we're going in. And now, a moment of destruction. I'm going to put a lot of pressure on the screwdriver. If it's doing something more than I realize with the pressure and power, something else is going to get damaged, and that's really not what we're after here. We don't want to damage anything, so power is dangerous. So I've got it up a good 1/4 inch here. I want to get cutters in there. Oh, how could I ever get cutters in there? And nip that wire. That would be great. How am I going to do that? What if I leave the capacitor there? Just leave it there. Fish the new capacitor lead down past it. Tie it underneath. try maybe to nip away the old capacitor lead at that point. This would come out then. This would fall out. If I push it back down now, or pull the lead, I've exposed some lead here. So if I get underneath and kind of crank it down, I've exposed some more lead. Maybe I'd be able to cut it down underneath, and have enough lead to make the reconnection. Let's pull it down. Pull it down. That's a famous phrase from something, isn't it? Which I won't go into. Okay. Well, the wire is pulled down so tight now, it's like there's nothing there to cut in the usual way. Kind of put a knife through it. No, I was going to push. Yeah, let's push the capacitor first, back down. Maybe I can do it like this. No, I have to turn the radio over again. Over and over and over again. Get a grip on it with a pair of pliers and shove it down. Even that's easier said than done. And grip. A really firm grip. Down you go. Ooh, well, something went down there. I have the feeling the wire bent just at the top of the capacitor, and that it didn't actually get pushed through, because that went a little too easy to me. And yeah, nothing happened down below here. Okay, where are we at now? Now we're back to trying to rip it off again. And go up and down a few times. Something's going to give. These really aren't ruggedly built when it comes to doing exactly what I'm doing. Pulling on them like this. There's wires there I'm trying not to damage. There we go. Is that almost fallen off already? I've already busted it up enough to pull it out of there. Okay, I've got to make some space for it to come out now. Grab the conductor here. No, grab the capacitor. Oh, it's giving up its ghost. Let's go out the side door here. There he is. Hey, his end's missing. Left all that behind. So what's special about this? So I thought this might be a metal shield, but it's just paper. 158 volts, 0.05. Well, it doesn't say too much on it. That makes you think it's something special. I don't think so. This is a pretty heavy. Just wondering if that's a metal can around there. I don't think so. Okay, 0.05. Oh, I gotta shove that wire down. Try to get it through now. If I shove it, if I grab the wire at the top and shove it, it's just gonna bend. I have to grab it right above the hole and try to shove it in there. Fat chance on that. How am I gonna do that? That's a real He-Man effort. How am I gonna do this? Okay, wait a minute. Maybe there's a different plan now. Maybe the plan is to leave this wire just like it is and solder to it down here. It sure does move. Let's take a look at what happened underneath. Well, I could hook that. A little hard for you to see. So I do have a tool. It would be useful. Try to hook the wire and then pry it out, because it did come up enough. Okay, I got it. Oh, it's coming right out. Coming right out. Now, I think the what's happened is the end of the capacitor has met the hole and it's not going to come through. So I think I can get up here and nip off the end. Just make it there. I should leave enough. Yeah, perfect. Perfect. That sounded kind of weird. How many things did I just cut there? 8 things? Now look at the old chunk of capacitor. What's left up here? Well, I guess I went flying. There it is. It's way down here now. So that's the terminal piece from inside the capacitor. Doesn't look like much, eh? Now, let me start this with dropping the capacitor replacement back down from the top. So it's a 0.05, wasn't it? I think it was. 0.05. There's a 0.05. We will drop it down from the top through the hole. Okay, it's kind of bumped in. Now let me. So what lead do you want longer? The last capacitor went from top to bottom. It just barely fit in there. This one I can move the capacitor body up or move it down. Closer to the ground or closer to the coil? How much difference would that really make? So probably more grounded wire is less a concern than more of this potentially antenna wire up here. Like this piece of wire here, the top of the capacitor can act like an antenna. But the one that's tied to the chassis sure can't. Where it went. Hope so. I'm putting it in the right spot here. Get rid of that excess wire here before it. So one of these coils, this one over here, has a big wire on it. I'm not too worried about hurting that one. This one's a little finer, but it's these guys up here that have very fine wire. You know, just one jab. Don't even do that, Jim, for crying out loud. That's exactly how sad moments arrive. I'm assuming there's enough lead sticking out the bottom. Yeah, I think it's. Still too much lead there. Oh. Phone in the pocket again. Shame on me. The other day I was in here working on something else, working on a signal generator for my listening post, and I had my phone in my pocket like that and didn't really think about it. I had the headphones on. My phone went and caused a noise in the headphones that made me almost hit the roof. Try to have this just out a wee bit. Good. Let's do that right away. Bring on the solder. What's this capacitor doing anyway? I'm not even sure. Just That's good. Just go underneath here. Okay, it's a little bit difficult to see up there. So if you think of a Van de Graaff static electricity generator, that's the kind with the big ball on top of the plastic tube. You see people put their hands on the big ball and their hair stands up and stuff like that. In the plastic tube, if you look, there's a belt running. The big ball on the top is what's interesting. The belt is, of course, helping with the generation of the static charge, and then you want to deliver the static charge to the ball and keep doing that again and again and again and build up the charge. Of course, the problem is once the ball gets kind of charged up, you can't jam more charge into it. So you wouldn't get too high of a charge. If you think about those balls, those big Van de Graaff balls, those things go up to, I don't know what, millions of volts, I think. How do they do it? How do they get the electrons to be willing to jump onto the surface that's already crammed with electrons? The way they do it is they send the electrons on the inside of that ball. They immediately transfer themselves to the outside where they live. They live on the outside. Can you believe this? The outside of it, you can draw an arc who knows how long. The inside, if you could do it, if you could reach up inside and go like that, nothing would happen. Well, good luck getting your arm up there without discharging the outside of the ball. But that's the name of the game. Same deal going on here. For some reason, this capacitor has got to be attached inside here. I mean, it's not static electricity, but there's something about the inside and the outside. Charges tend to live on the outside of things. Yeah, I guess that's just, maybe it's just simple forces of the repulsion, repelling forces. Maybe just kind of push everything to the outside. I don't know. But that's how those things work. So the Van de Graaff generator puts a little charge into the inside. It has electrode just a distance away. And as the belt charges up the electrode, it sparks a few more electrons every time, and they collect on the outside until there's so many of them they are going to get off. So, or make your hair stand on end. Well, I just kind of lost track of exactly where I was with this. There. Put a little solder on that. Lovely. There we go. It can be very tricky soldering those connections. If you attempt to go right into the solder pool on the chassis, you better crack out your great big 1000-watt soldering iron. So I try my best to leave a tidbit of wire on a connection like this when I'm going to remake it, and then solder to the tidbit of wire, which is just what I did there. Now, is that every capacitor in here? All the paper ones. The rest of them are highly reliable capacitors. Not that they are a guarantee, but there's no reason to change them without evidence of need. So now we're going to try to operate this radio, and with any luck it's actually going to work reasonably well. But we do have to have some luck. So one thing I'm going to go turn the antenna on down yonder. Okay, let's see what we get this time. Just making sure everything's safe. Put some voltage to it here. Oh, to turn the voltage on. Okay, we've got there. 90 volts. Not switched on. Here we go. How many times can you turn something on? Quite a few times, apparently. 75, 80. We're still going through the dim bulbs, so there's a little bit of voltage loss there. Okay, radio. Let's hear you. 90. I'm going to take it up a little higher because 90 is just too low. Still going down. Okay, so I'm going to switch the dim bulbs out of the circuit here so we can get the voltage up a little higher. Take this down. About 100 volts now. 96 here. It's really, I'm fooling around with this voltage thing way too much. Let's take it up to where it should be, roughly about there. Hello, radio. Come in, radio. Well, it's pretty quiet from what I can hear. Okay, we're gonna. Oh, a little noise there in the speaker. I'm gonna just inject some sound here. Oh, my whole bench is just shaking. Wow, low bass. Okay, so we're going to put on an antenna. I took the time to actually switch the antenna on, so this is actually hooked up to a real outdoor antenna. Let's see what we get here. Wow, disappointingly weak. Some mechanical squeaking going on in here. Well, I tell you, it was working better before. Oh, wait a minute. It's not the most healthy sounding radio, is it? Lots of heterodyning in it. Very little volume. It really doesn't bode very well for me. I'm going to connect the antenna ground to the chassis here. Just weakens it. Well, it could be that its alignment is just so far out, and this is what you get right now. If that's the case, we should be able to find the signal traveling along here fairly well. Okay, back to the signal tracer. At least we're trying to figure out where things are getting weak. That's really quite disappointing. I'm expecting a lot more out of this at this point. I never did the capacitor that is on the incoming power line. That's what I really meant to do. Get that one next. So first we're going to try to listen to the actual radio signal on this grid. You can see this tube is hooked right up to the capacitor. It's practically hooked right up to the antenna. Set our signal tracer on RF. Band B. And the radio is currently tuned around 650, so we'll tune this around 650. Now, so theoretically, the antenna you see down here should be going through, and there should be lots of stuff to hear on here. And the volume on the radio doesn't do anything at this point. Here we go. Just can't make a good connection here. What happened to you? You're making funny noises and then you stop. Okay, up on the volume here. Tuning. Oh. Okay, tuning. Pretty weak, wouldn't you say? I mean, it's hard to say what's really going on here. My signal tracer is basically blasting. It's up really high. That's why if I move a bit, it makes so much noise. Not much here. Yeah, really, not much here at all. 600. Okay, well, we'll go here anyway. Let's see what's going on. Sometimes doing these tests disturbs the radio as you do the test. Now, it shouldn't be the case with this guy. This great big thing here has a vacuum tube inside of it, and the grid is coming out. That's all this is. It's just a grid to a vacuum tube. So the impedance of this should be billions and billions of ohms. Having said that, oh yeah, we're going to try to hear the IF signal. So the IF signal is at 456. Feedback. So 456 would be roughly here. It's there. It's gaining. It seems to me to be extraordinarily weak. Weak right from the start. Okay. Now, what we can do now, we can be the antenna. I'll be the antenna on here. Let's see if that juices up the radio. I gotta turn up the volume. Next to nothing there. So that's helping it a lot. So this is a bit of a weird one to be touching. The tuned circuits through here, so the noise is going through. What's the matter with the antenna? It doesn't even. Nothing. Okay, well, that's a good thing to start investigating tomorrow. So basically, I've driven this radio's performance right down into the junk pile, changing capacitors. But we'll now try to resurrect it. So there could be a defective resistor in there. Some of these highly reliable capacitors. It could be one that's got a short or is open. There could be something more I haven't found yet, or it could simply be alignment and tuning. At this point, I kind of doubt. But tomorrow we will find out. Hey, thanks a lot for watching.